All right, now we're going to look at 7.5, which is properties for logarithms. Now, this part can be a little bit difficult at first, and we're going to try to keep things fairly simple when we go through this. So let's just get started by looking at the actual the general way we write these. So the product property of a logarithm essentially is saying that when you have a log base b with m times n here, the way that you rewrite that is by saying that log base b is actually rewritten or can be rewritten as log base b of m plus log base b. Let's see, let me actually zoom in so that we can fit this all in here. Okay. So log base b of m times n is rewritten as log base b of m plus log base b of n. So essentially, when you're multiplying with logarithms, you rewrite them as adding, or you can take the adding. If two logarithms are added together with the same base, you can rewrite that as multiplying. So here's what that looks like. So when it says to condense these into a single logarithm, this is how you do it. You take this property and you're going to rewrite it based upon that property. So if we look at number 1, we have log base 2 of 7 plus log base 2 of 4. So we rewrite this by combining log base 2 and condensing this into just saying log base 2 of 7 times 4. And then we can just simply simplify this to log base 2 of 28. So you'll have to just mentally make yourself a note. Anytime you see two logarithms with the same base added together, you can rewrite them as multiplying. That's how you condense it into one single logarithm. So we'll do another one. So let's look at 2. We have, well, actually, yeah, we'll look at 2. That's fine. So we'll look at 2. So 2, we have log base 10, understood, of 25 plus log base 10 of 4, or you could just say log 25 plus log 4. We need to combine these or condense this, and we have these two added here. So that means by our product property, we actually combine those and multiply them. So we'll have log of 24 or 25 times 4, which will give us log of 100. Which, like I said, it's understood that we have a base of 100 there. Now, the only additional part that can kind of just give you a little curveball is like in number 3, we have a log base 4 2x of 2x plus log base 4 of 4x squared. So, like I said, we're going to take these two and condense it into one logarithm, log base 4 of, since this was added, we're going to say 2x times 4x squared. And the only thing that you really have to pay attention to is that this is a product rule problem for our rules of exponents. So when we condense this further, simplify it, we'll have log base 4. 2 times 4 is 8, so it'll be of 8x. We have x times x squared. In order to perform that, we have to add our exponents, so it'll be x to the third. So that's the only real part you need to just pay attention to is your rules for exponents. But that's it for looking at condensing our logarithms. Now, if we want to expand them, we just do the opposite. So if we want to look at expanding them, we'll already have a setup where everything's like combined for us, and then we just need to break it down. So if we want to look at number 4, we have log base 10 of 6, or just log 6. If we already have that set up, we need to break down 6 into 2 factors, which these answers may vary. we need to break that down into two factors. So we'll have log base 2 times 3. We could use that to break this down. And then that would expand even further into log base or log of 2 plus log of 3. So it will even further, we're basically just doing the opposite of what we just did. So we'll start off and say that we have two factors multiplied together, then break those down and say that they are added together. So we're pretty much starting with our property looking in the form of log base b of m times n, and then we're going to break that down into them being added. So we'll look at another one. Well, let's look at number 6 to try to save you some time. So number 6, we have log base 2 of 5x. So if we want to break that down, here we have 5x, which is saying 5 times x. So if we want to break this down, we'll have log base 2 of 5 plus log base 2 of x. So essentially all we have to do is say that those two are added, but they each have to have that same log base 2 portion at the front. So that's your product property. Now the quotient property is very similar, except now we'll have subtracting, and in turn, when you condense this, that means you're dividing. Or if you want to expand it, it means you'll be dividing and then subtracting. So let me give you the general form first. So the quotient property says that if we have a log base b, or any number, with m divided by n, we can expand that by saying log base b of m minus log base b of n. So it's just the opposite of the product property. Now we're going to have a minus sign in the middle, or we'll have to expand it and end up with a minus sign. So let's look at condensing first. So if we look at 7, we've got log base 3 of 24 minus log base 3 of 8. So if we want to combine this, we're going to take our log base 3, condense that down to just one log base 3, and then in parentheses, we'll have 24 divided by 8 since this was a minus here. Then if we want to further expand this and simplify it, we'll end up with log base 3 with a base of, or a base is 3, and then it'll be of 24 over 8, which is 3. So we would get log base 3 of 3. And then we'll look at a little bit of a harder version. So in number 9, we've got log base 4 of x to the 9th power minus log base 4 of x squared. So this minus tells us we're going to condense this, and it's going to be a quotient property problem. So we'll condense this by saying just 1 log base 4 will take x to the 9 over x squared. So since that was a subtraction, we divide those two, and then that will end up giving us log base 4 of x to the 7th. Now the reason that it's x to the 7th, because this is a quotient rule for rules of exponents. X to the 9th divided by x squared. We take those two exponents and subtract them, and we will get x to the 7th. So that is condensing our quotient rule. Now our quotient property. Now let's look at expanding it. So if we want to expand it, let's look at number 10. We have, and these answers may vary as well. So we've got number 10 as log base 8 of 4. We want to condense that using the quotient property. So we're going to need a log base of 8 with two numbers divided to give us 4, which we could use 8 and 2. So 8 over 2 would give us 4. And then we just have to expand that, because anytime we have a log base b, here it's log base 8 with two numbers divided, our quotient property tells us that we can pull out 8 over 2, separate that with a log base 8, and have a minus sign in the middle. So we'll get log base 8 of 8 minus log base 8 of 2, and that would be our answer. So it's just going in the opposite direction is what we did with our condensing. It's just the opposite of our condensing. So then I'll show you one with a variable in it. Number 12, we've got log base m, or log base of 10, but it's just understood to be 10. So we've got log m over 7. So that's set up just like our general form here. So we don't really have to do much simplifying or expanding. We can just go ahead and rewrite this with a minus sign in between. So we'll have log m minus log 7. So that is expanding the quotient property and condensing it. Now the last thing is the power property. So the power property, we're going to try to stick to some easier problems with this because they can get pretty crazy. But the power property is saying that if you have a log base b with m, or of m, and you have this exponent that we call n here, you can bring out that exponent and bring it to the front. So you would have n log base b of m. So that's all that's saying. Or you could go in the opposite direction. So if you want to condense it, you'll go in the opposite direction. So let's look at some problems. So 13, we have 5 times log base 4 of 2. All we do with this 5 to condense it is take it and make it an exponent of a, which in this problem, or m, which in this problem would be 2. So it'd be 2 to the 5th power, which we can reduce that even more, and it'll be log base 4 of 32. So that's all you have to do with these. These are pretty simple. These are a lot easier in my opinion. And then we'll look at another one. We'll look at a little bit of a harder one. So 15, we have 1 over 3 times log 8. All we do is take this 1/3 if we want to condense this, and that means it's going to be our exponent of 8. And if you want to draw those arrows for yourself, you can. I'm fine with that. Now this is a bit of a review. If we have if we want to reduce this even further, we can. If we have a exponent of 1/3, anytime you've got a fraction, we need to rewrite this as a radical. So our denominator here tells us we have an index of 3, so this would actually be a cube root of 8. But I'm not going to get too hung up on that, just because I really want you to understand condensing and expanding these. So then let's look at expanding, which is just going to be doing the opposite. So now we'll be left with we'll already have an exponent here, and in our general form that's n. Now we take that out to condense this or expand this. We take that out to the front of our logarithmic equation. So now we're going to rewrite this as 7 log base 2 of 8. Now the only time that this can get a little confusing is when you have a number that's already here out in front, and then you have this exponent here, because we take that exponent of our logarithmic equation and bring it out to the front. So we'll actually have 3 times x minus 1 log 4, and then we have to distribute here. So we'll end up with 3x minus 3 log 4, which that's not too hard, just it can give some people some problems. Now in 18, this is part of the review as well. So if we have 18, we've got log base 7 of the square root of w. In order to know what to bring out and multiply in front here and expand this, we need to know what this exponent, or how to rewrite this exponent of our square root, which the exponent of a square root is just 1/2. Because the index here is understood to be 2, that's our denominator. W is not to a power, so it's just going to be w to the 1/2, and then we'll bring down our log base 7. So now we take this exponent of 1/2, bring it to the front, and it's multiplied, so it'll be 1/2 log base 7 of w. So that is the power property, the quotient property, and the product property. And product property is just if you have 2 logarithms, or logarithmic equations or two logarithmic forms added, then you can rewrite those as multiplied, your two numbers, and you'll just keep your log base the same. If you want to expand those, you'll just take it from just a single log or logarithmic form and break it down, and you'll end up with an addition sign if you want to use the product property. The quotient property is the same, except it's just opposite. It's just subtracting now. And then when you expand it, you'll end up with a minus sign. But when you condense at the very beginning, you'll go from a minus sign, which tells you that you take your two numbers or your two variables, and you will divide them. You'll divide those. So then our power property, I think, is the easiest part. If you have a number out in front multiplied and you want to condense it, that number now becomes your exponent. If you want to expand it and you have an exponent, now that exponent becomes your lead coefficient, or it's just out in the front multiplied by your logarithmic equation. So we'll do some examples of these in class, but that's going to be all for this video.